All right, let's get it going. So if you click on this presentation in R Fundamentals 01, okay, click that link that says presentation, and that's going to I'm going to present it just from the web. Okay, so class is about elementary data types. So we will be going over the very basics of R, and when you click on the next link, so everybody has R Studio, right? I sent out an email that everybody should be having R Studio. So that's key for today. And subsequent lectures, we are just going to work in the console panel of R Studio. So if you open the R Studio, there are going to be panes. Okay, the top left most part of the pane is the editor, and that's useful for several other scripts, for R scripts and R markdown files that we would be focusing on. The downward is a console. So today's class, and I think the next two classes, we are going to primarily focus on the console panel of it. Okay, and to your right, topmost right of it is the environment. That's where the history and the whole environment gets stored. And if you are having a Git, there is also a small Git menu tab that you can write and then push it to GitHub. Okay, so one of the things that I would suggest at this point is to get familiar with Git, and also the link that I was telling you the last time, right? I mean, about the Git and RStudio interface. So it will be great if you can get it working in the next couple of classes, that the interface between Git and RStudio, because after a while we will be doing everything in RStudio and pushing it to Git. So it's critical that you work with the Git R interface, and if you have done that, you will see the Git panel there. But if not, it's fine, you will not see it. For today's class, it's not important. Okay, and then you have the bottom right panel, you have the files and other tabs for it, right? So those as you and also the plots, if you want to draw any plots, it's going to show up in the plots, and also packages, right? All these packages that's going to pop up in the packages window. So there are lots of things here. RStudio is a very neat package for managing whole R system. To the next slide, we can customize all of them. Okay, so there is a, if you click on the link customize, there is a big tutorial on how to customizing RStudio. Okay, you can go there, read if you want specific fonts or specific type of an interface that you want to look into, you can do that. So that's the customize panel. You can go to the tools in RStudio and customize all of them. But initially we will be working only with the console, okay, before moving on to the editor. So for today's class, we will be just working with the editor. Okay, let's dive right in. Assignments. So these are the very preliminary things in R. The first thing is the R interface, right? It's made of, everything is made of objects in R. How many of you are used to object-oriented programming? Okay, that's a different paradigm compared to the functional program, the procedural programming, right? Pascal is a procedural language, whereas C is a procedural language, whereas C++ is an object-oriented language. So R is essentially an object-oriented language, and assignments usually take this form object, and then there is the less than symbol, and then the hyphen, and then the object value. So that you can think of it as object gets object's value. So that's what you read in when you see that. So for instance, one can assign, for instance, x is assigned to 5 plus 13, and then if you print out x, it's going to give you the value 18, right? So that will reveal object gets the value 18. The double hash is the result that they should appear in your console. So usually you will see that this is all what you get in the console, right? If you type in that console. So the first part of it, I'm just going to go over it, and you will have time, plenty of time to practice this hands-on as we move towards the end of the class, right? And we'll be using lots of assignments. And you may also note that equals will work for assignments, but it's best to use a specific assignment function as provided by R than using the equal to sign, because equal to is usually reserved for things within the R arguments. So if there is a function and you need to assign values to arguments, you use the equal to sign. in general, it's a good practice, and then to use this kind of an assignment, function to read R codes and to write. So don't be lazy and just use equal sign, but use this notation for assigning variables to R. Okay, and also it has a shortcut. If you click on Option plus and minus in Mac, or Alter plus and minus in Windows, you will get this shortcuts. And for a comprehensive list of shortcuts, there is already a web page for it. So you can click on that page to get a comprehensive list. Okay. Also, Option Shift and K in Mac in RStudio will bring keyboard shortcut reference card. Okay, so these are some of the tips that you may want to have in handy, when you're working with lots of data analysis and code, right? And RStudio automatically surrounds the assignment operator with spaces. So it's for readability, to enhance readability, RStudio makes all these provisions. This you won't get in the primary R console, right? And objects cannot start with certain characteristics, such as snake case, or you can use snake case or camel cases, but it can't start with numbers or comma or space. Okay, so there are some good naming conventions that you use. One of the key things that's very important for data analysis is to have a certain type of style, that when you code, have a certain set of practices, and don't mix up camel case with snake case. It's going to be a mess after a while. So these are some of the things that you stick to conventions, even starting with capital letters or small letters. I mean, these small things matter in a long term. So these are the small things that you need to be really focusing on when you start doing data analysis. So whatever convention you prefer, maintain consistency. Okay. And consistency and accuracy are critical. So the first thing is, when you run into errors, you check the typos. That's the basics. Most of the times I have seen that typos actually contribute the maximum of errors. Right, 90% of the time there is going to be a typo. There are some errors that could be resolved, but other than the typos, but those errors are really short when compared to what human errors are much more than that of the compilation errors and things like that. And there is no other way than getting better at typing and then checking and rechecking the code. Okay, so that's something important. And for strings, right, you can assign strings to objects using quotation marks. So for instance, R rocks, right? I mean, just if you put it in quotation mark, it is going to assign that string. And this is a classwork that we will go later. As I told you, the first part is I'm going to go over the entire the whole material, and then you will be working on all these things. As we progress towards the crows, you will have lots of such classworks that's been assigned. Okay, so this is a simple classwork. You assign the string hello world to object H and print the result, right? So that's a simple classwork. R scripts, whatever that you do in the console, that you can write a separate code in the editor and do it. Okay, so if you go to RStudio and go to File, and then if you see that it will ask you for a new opening. If you are opening a new project, it will ask you for a R script or R markdown, and there will be lots of options. So you can start an R script. So whatever that you write it in console, you can write it as a script, and then you can say run. So it's going to run it. For the for the classworks, when you're submitting the homework, you are going to, for the initial 3 classes, you are going to submit it using the R script. You are going to put whatever the classwork is there, you are going to put it as an R script and submit it. So if you go to File, New File, the first option is an R script. So whatever that you are writing in console, you can write it here and then say run, and it's going to run it just like what it will run in just like how it runs in the console. Okay, so the second exercise is to do the above classwork as an R script and run it. Okay, so to get you a feel of how R scripts work. So once you put the object into R, you want to remove it, or you want to know how long the object is going to be there. So during an R session, objects are created and stored by name. So for instance, if you want to check the list of objects, you type in the keyword objects, and that's going to display the objects that are currently stored in the session. And the set of all such objects is known as a workspace of R. Okay. For removing objects, use the keyword RM. So RM of R would take away the previously stored object R hello world, which has been assigned hello world, right? So it will remove the object R that was created above. And to remove multiple objects, you just list it by comma, RM, R, comma, X, etc., etc. Functions. So R has a wide built-in range of wide built-in functions. Okay, so that's R is an open source, as you know. So there is a tremendous amount of community that's dedicated to developing resources in R for applications in R dedicated to any specific purpose. So it has a wide range of built-in functions, and usually the functions are of the form function name and argument equals value 1, argument 2 equals value 2, etc., etc. And this is where usually the convention is to use the equal sign within the functions and not as an assignment. So not all functions will have arguments. For instance, the function date, right? When if you print in date, it will not have any argument. It's just going to print you just the date. So one of the extremely helpful feature of RStudio is the question mark symbol operator. You can use this to find the description of the function in question. Okay, so question the function to know about the function in question. So for instance, if you want to know about the date, you just put a question mark and date. If you want to know some complex model, linear regression, and if you want to put a question mark before that and then put the function name, it's going to list out and tell you exactly how the function operates. You will see that in one of the windows in RStudio in the help menu. It's going to immediately pop up and it's going to tell you, and it's also going to give you an example of how you have to use that function. Okay, so that's a key usage, and that's a key thing to know when you are stuck, when you want to know help. When you want help, you just put a question mark symbol. So, and another tip is that when you don't know the function, when you type in a part of the function and hit a tab, RStudio will auto-complete the function for you. It will suggest you hints on what are all the possible inbuilt function for that, that's starting with that letter. So if you type an open parenthesis, RStudio will supply the closed parenthesis. So it comes in pack. I mean, sometimes it may be difficult when you got used to opening a parenthesis and then closing it. Then sometimes it may not.
It's not working?
Yeah.
I know why. It's because that. See it?
Which one?
The projector. So basically,
Oh.
my cable out.
Okay.
So I just need to get on top of that end real quick. That's the reason why. That should get it to work.
Oh, I'm not able to use the DVI. No, it works
Not
great.
everything works. Yep.
The DVI should work too.
Well, that's the HDMI.
Oh, this is it's
Yeah.
sort of the HDMI.
Yeah, right here. Hold on.
Yeah, it doesn't really, but I think it should be fine. I'll
You
use
wanna
the
use the VGA?
I'll
instead?
use the VGA.
Yeah, I'll use
Yes,
that.
yeah, that should be fine. Okay, I think it should work.
Yeah. Great.
Great, thanks,
Awesome.
man.
Yep.
So it will type you a closed parenthesis, right? It will also supply with a closed parenthesis. So you have to get used to that style of programming. And if you type a function name without a parenthesis, R will print a source code for that function, which you may not probably want. right? If you just type in the function, it's just going to print you the function, the whole of the function, which I mean, except for variables, which if there is an object, that it will print the object's value, but otherwise it's going to print out the whole thing. So now consider the seek function. What does it do? Don't have to do it. You'll have time to do it. Okay, so the seek function also, if you question it, you will see that it has from and to variables, right? You can specify numbers from 1 to 10. So to do that, just specify the numbers. And so also remember that seek, if you don't have to use the first two arguments, you can also use seek 1, 10. It's going to print the same thing. We can always specify from to value, or even without that, the arguments gets resolved in OR automatically, right? But so it's always best to do it, right? It's always best to specify the arguments. These are key programming practices that's very, very important for good data analysis. So even though the arguments gets resolved, you don't want to leave it by default for R to resolve on its own, because there could be lots of confusions later on. Simple manipulations, vector arithmetic. The function C, you will see that all the time. Whenever you see an R code, you will see what does C. C is just a combining, right? So it will combine values into a vector or a list. So C is just a combined function, right? To set up a vector X, let's say some consisting of 8 numbers, some random 8 numbers, you can say that C, 12, all these numbers, you can list it. If you give it in the open parenthesis, it's going to combine and form a list. So this is a vector. So this is a vector that is the vector is not, we have to be careful whether it's a vector or a list. I'll go into the details later, but it's important to note that this is a vector. Okay, so it will assign the vector to the object X. So the C is just a combining operator. And also we can form mathematical expressions just like any other variable. For instance, if you want to type in the sign of X, just specify sign, and it's going to take the vector, and then it's going to produce the values of sign for each of those values in that vector. Okay, for square root of X, it's similar. So it's going to take, for each of those values, it's going to take the sign and then the square root. So that's how it operates. One of the neat features is that we can also combine a vector with itself. Okay, so if you say that C of X comma X, where X has already been assigned, it's going to combine the two vectors and put it in a one big vector, right? So we can also use this to include some numbers in between. So I'm including the number 0, can do that, and it's going to put the value 0 in between those two vectors. So this is one of the greatest advantage of R, probably, as opposed to MATLAB, for instance. Like when we want to combine vectors of different length, it's going to be tough. In MATLAB, it's usually you have to, it's labor. I mean, it's very difficult to combine two vectors of different length, right? I mean, but in R, let's say that if you want to combine one vector which is twice as big as the other vector, you just say it's you just add them, right? So what does R do in this case? Let's say 2x plus y plus 1, right? Where y is twice as that, at least twice as that of the first vector, right? So what R is going to do is what is known as a recycling. Okay, so what it's going to take the biggest vector, which is 12, 20.1, etc., etc., which is twice as big as the first vector. Now it's going to take the second vector, which is 2x, right? And it's going to recycle this vector, which means that it's going to paste the vector over and over again until it meets that length. Okay, so it's this vector twice of this vector, right? It's going to just paste it, and then it's going to if there's a constant, it's going to replicate itself as much as the number of values in there, and it's just going to add it. So that's how R operates. So when it's okay to give two vectors, and you have to be careful about this. I mean, because of this recycling, you have to be extremely careful when programming. It's not typically, it's good and bad in some ways that, but for some data analysis requirements, this kind of a structure is necessary. And this recycling, you will see it often and often. It comes in data frames and it comes in several other data structures. And several functions work as usual, like mean, minimum, maximum, sort, etc., etc. It's going to be just the same. It's not going to be too tedious. Okay. So, what about complex numbers? What are complex numbers? Anybody here? What are complex numbers?
There are numbers that have a real part,
Mm-hmm.
and oh my god, I don't know the English word. I'm so bad about it. It's actually a generalization of real numbers because people were trying to resolve the issue of having square roots of negative numbers.
Right.
So they create complex numbers in order for the square root function to have an outcome, a result when it comes to negative numbers.
Right. That's right. So it's called imaginary numbers.
Imaginary, yes.
So when you are trying to solve the equation x square equals -1, right? There's no real values in there. So those numbers which have those are called complex numbers, which also have an imaginary values. And this is very important because when you're solving some real systems, the polynomial systems, where you will have these kinds of roots of the polynomials come in imaginary parts as well. So it's much more important, especially working in electrical engineering and things like that. These complex numbers appear often. So as such, the square root of a negative number, like square root of -9, right? Negative 19 will return n, not a number, and a warning. But if you include 0i, that will work. Usually, the complex numbers are of the form a plus bi, where I is denotes imaginary, right? So that's so we have to give 0i for R to recognize that as a complex number and print it out. Right. So logical vectors. That's so far regular vectors, and you can include logical vectors, which happens which is very important in public data sets or data sets that you collect for on several other statistical problems, right? You need a logical vector or categorical values that can be converted into logical vectors. So it allows the manipulation of logical quantities. So the logical quantities are true, false, or NA, not applicable, right? Or logical vectors are generated by conditions usually, and this assignment, right? You are assigning x greater than 13 as a logical vector. It will immediately identify this as a logical operation, and the logical vector corresponding to these elements is going to be printed out. Like if it's x is like greater than 13, it's going to print yes, otherwise no. If it's not a logical vector, it's going to say it's not a false, right? It's either going to print as true or false. Naming vectors. So you create a numeric vector by using the the combine function, and you can name the vector as you can determine some characters, and then you can use the keyword function names of v and assign it to n, so that the names of these values are going to be assigned to these values that you specify here. So this names function is going to assign these values. So R automatically takes each of these values and correspondingly it puts into these naming values that you assign. Also, you can name it within the combine function, right? So that's instead of assigning separately, you can assign within the function 2 equals 2, 15 equals 15, etc., etc. This is much preferred way of doing things, because sometimes you have to be really mindful here. You have to remember this. I mean, in this case, this is simple, but in other difficult cases where you have some vector and you have to match it and then assign it, rather you can do it within the combined function. And so that's a very useful way of defining names in the vector. So as a class work, what happens if you type names of n equals v? What does if you put it in the reverse way? right? What if the length of the vectors are not the same, either the length of the names or length of the values? And what happens if you label two numbers with the same name? So these are some of the classwork that you have to do after this and see what happens. So one of the key things to do doing data science is being curious. Okay, so these are the things that you need to try it and test it out to see what works and what doesn't work. Subsetting vectors, you can access each vector by the values. So C12 is going to print the values of the vector V at this location 2 and 15 with the names 2 and 15, because the first element is 2 and the second element is 15, right? Or you can subset by name. Instead of 1 and C1 and 2, instead of specifying the first vector and the second vector, you can say I want the vector that has the name 2 and I want the vector that has the name 7. So it's going to print out the same the printout corresponding to these names, right? And you can subset all of them except one by doing by appending a negative before the combined function. So it's going to print out everything except the first one and the vector at 1 and the vector at the element at 1 and the element at 2. So which is going to be 5 and 7. Yep.
I have a question. So it always starts at 1, not 0. It starts at
Oh
1
yes,
for
the naming, yes, it
Okay.
starts at 1. So that's the convention in R. Yeah. So what happens if you swap the index? So that's something that you have to try it out. And what happens if you subset by the name not present, right? 2 and 3. And does subsetting some operation work with names, right? I mean, so you can subset some of them and whether that operation works with names, right? And also you can subset using logical vector. Okay, oh, maybe I think this is probably not present in here, but should be able to go here and see. So you can actually subset using the logicals, and that subset using the logicals, right? So 15 and 7. So you should you can what happens if the logical vector has less than the required number of elements? That is something that for you to try it out. Missing values. So most of the data that you encounter outside, right, it's going to have lots of missing values. And this is something extremely important. This is called data cleaning, data wrangling, and things like that. So the function is.na of x gives a logical vector of the same size as x, and if it's true only if the corresponding element is na. If you have na, it's going to print true, otherwise it's going to return false. But if there is no numeric value, if it's not a number, it's going to return true for na and 2. So to distinguish between these two, R provides the function is none that returns true only if there is a none in here, not a number isn't there. So the missing values is something extremely important. Make a vector of length 5 with na in them and test for the missing values using is_na function. Okay, so that's a work, one of the class work, and extend this to a vector of length 5000. So this is just 5 vector of length 5. You have to extend this vector to the length of 5000. So it's up to you how you are going to extend this, and there are functions to do that. We already covered those functions. Character vectors. Character strings are entered using either matching quotes or a single quote, double quote or a single quote, and or you can specify sometimes without quote too. It's going to what is known as a coercion. I will come to that later. But there is another interesting function called paste. Okay, so the paste function, it takes arbitrary number of arguments and concatenates them together to form a single string. So if you say paste cx comma y and ab comma b, it's going to paste these list with that list or this vector with that vector and form a combined list. Okay, so that is something that it's going to do. So by default, if you do a paste, there will always be a space between these two values. Okay, so that's a separator that R automatically puts into place. Okay, but this can be changed by using what is known as a separator string. So if you say that I don't want any space between them, just say sep equals and nothing in there, and it's going to render the arguments together. So here in this previous one, you had the space y, and then there's a space between a b comma b, right? There is a space in here, and that disappears here, and you have something together. So play with the separator argument to include other type of delimiters, comma, etc. That's something that you need to do. Basic objects and data types. So far we have seen vectors, right? So these are the basic objects and data types, is vector. One of the fundamental difference between vectors and other data structures is that, or even, so one of the other, okay, let me go to matrices. Matrices are just vectors, two-dimensional vectors, right? You have rows and columns, but they are similar to vectors in the sense that matrices also if you say matrix, it's of a unique data type. Either it's all integers, it's all double, or it's all characters, right? So that's the basic data types are made up of one single data single data type, either integer or characters, right? Factors provide compact way to handle categorical data. So factors would provide categorical data. So for them, there is a specific name for it. It's called factor. Lists. Data frames. Lists are similar to vectors, but the key difference between list is that you can have multiple data types. One can be an integer, one can be a character, the other can be a logical. So list can do that, but a vector cannot do that. If you say vector, that means that everything is an integer or everything is a character. A linked list, actually list is a shorter form of what is known as a linked list in computer science data structures. Okay, linked list is you can have any type of data structures in there. One could be an integer, one could be a character, right? So this is a very powerful data structure, and we will see that in the next class, not today. Today we are just going to go over vectors and matrices, which are basic data types. Data frames are even powerful, right? It's a matrix-like structure, but it can handle different data types. Okay, one can have a list. One can be a. It's essentially a list of different. It's a list of lists, but data frames are matrix, but it can contain multiple data types. So that's the key difference. Whenever you see data frame, you have to remember that it could be of multiple data types. For instance, an Excel sheet or any data that you get outside. It's some numbers, some logicals, some string. So data frames are a perfect data structure for manipulating those types of data that you get from outside. Okay, and functions. Yep.
Is one structure better than the other in terms of how our processes that? Like if you have a data frame in the same type, is it going to be processed less efficiently than a matrix? Or?
So there are certain rules and regulations for what constitutes a data frames. So for instance, in each data frames are nothing but they are lists essentially. They are list of lists. So each column will be made up of it should be of the same data type. So from the processing perspective, it would be processed as much of the list, but then the time and things like that would depend on the data set, underlying data set. But yeah, right. But in general, if you say it's a vector, it's much easier for R to manipulate things with a vector than with a character, or from the fundamental processing perspective, because everything ultimately boils down to changing the numerical, right? That's why if you have lots of categorical variables, R would automatically change them to a numerical variable and store it for computations, but it's not going to show it outside. But the way things are manipulated from the processing perspective would depend on the data, the types of data, and the data type, and the number of data that you have. And functions themselves are objects which is stored in the project workspace. Okay, so Data types and coercion. The function class can be used to reveal the data type. So the logical is made of data types true, false, or any. The numeric data types could be real numbers. And for integers, R has a specific convention that you can attach L to number, which will immediately interpret as integer. So 2 minus 2L is an integer for R. L stands for long format, which is 2 power 32, right? The total number of bits that you can assign, right? And character, R does not distinguish between strings and characters. Okay, so whether it's a string or a character, it's processed as the same. So, whether you specify R or R data type rock, etc., it's just going to be interpreted the same. And there are other atomic variables like double, complex, and raw, which probably we will not cover, but know that there are other data structures. So to reveal the class of the logical true, you type in class and then true. It's going to print out if it's a logical or not. And for numerical, it's going to print out as numeric. So as such, it doesn't distinguish between numeric and integer unless you specify it using the L. Right? If you say class 2L, it's going to print it as integer. But if we are just going to print as class of 2, it's going to interpret it as a numeric. Okay? And a class of this whole string, it's going to be character. So you can use this class function to distinguish the data types that R stores inherently. Right? And one can also use this function is data type of Y to reveal the underlying data type of the variable. So for instance, is logical of X will return true if X is a logical variable, otherwise it will return false. So one can force a data type into another through what is known as a coercion. Okay, so this is very important, and this would be applied by R. As soon as it sees the data, it will try to coerce. So like for instance, let's say that you have an integer 2, right, and a character, say C, right, and you are going to say, if you are going to make it as a list, combine these two, R would immediately coerce this number 2 as a character. Okay, it will force the data type because it's a vector, so vector should have the same data type. So to make it different, you have to use list or a data frame. If you want to store different variables, if you want to store different data types, you have to use list or data frames. Otherwise, R is going to coerce everything and make it as a uniform data type, okay, with the process known as coercion. So for instance, you can coerce true to 1. So it will just saying that make this true as an integer, it's going to make it as 1. And if you coerce false, it's going to make it as 0. Okay, coerce 2.5 as a character, it's going to make it as a character. You will, if you type in, you will see that it's within quotes. The 2.5 will be now within quotes, saying that it is a character. Okay, so this is very fundamental, and that's very important because sometimes you will get into error when there are different data types that doesn't match and things like that. Matrices. Matrix is a rectangular array of rows and columns. Right? Okay. So I think some of you who might want to know more on what matrices are, you should come to my linear algebra class on 27th. Okay, there I'm going to talk about what matrices are. But for our definition, matrices are just rows of array of rows and columns from the definition of computer science, right? So matrix 1 through 6, this is how you create a matrix, by the keyword matrix, right? Once you make a matrix, it knows that R immediately knows that all are going to be the same data type. So even if you type in characters, it's going to coerce into integers. Okay, so this is going to make matrices, and you can specify this row, end row equals 2, which means that make 2 rows. And by default, it's going to it's going to print out through columns, okay? And now also you can specify n column equals 2, okay? So it's going to print out, use 2 columns instead of 3 columns. You can change this default character. So by default, this prints 1, 2, 3, 4, 5, and 6 through columns, right? You can change this default character by specifying by row equals true. So in that case, it's going to put it as a row and not as a column. It's going to start as a row and not as a column, okay? And obviously, you can specify both rows and columns. N row equals 2, n row equals 2, and n column equals 3. It's going to print rows and columns. You can also paste rows or columns using the function cbind and rbind. Okay, so this is a very important function that you'll always see in the codes, cbind and rbind. So what this means is that cbind will bind, it appends the column, right? So combine 1, 2, 3 and 1, 2, 3. So it's going to make these 2 columns, right? Rbind will combine rows. So just like cbind, this is column bind and row bind. So it's going to make it as rows, okay? And also you can name a matrix using row names function and column names function. Just like we use the names function, we can use the row names and column names. And matrices can also be combined using the cbind and rbind function. Okay, so that is something that that could be done with both cbind and rbind function. Classwork. What happens if the number of rows and columns are more than the generated numbers when using the function matrix? What's going to happen if you have more number of rows and columns? What happens to cbind and rbind if one of the columns have more numbers than the other? Have to combine 2 matrices using cbind. Can you bind 2 matrices of different data types? What happens if you do that? We're going to test these out. Subsetting a matrix. You can subset a matrix using this function, matrix. You can access the matrix to the indices. So here I am accessing the matrix through the index 2 and 3. Okay. So it's going to give that number 8 because 8, the 2 and 3, the second row and the third column contains 8. Print all the elements in row 2. You can just use a comma and then the column, it's going to print all the numbers in that column. And similarly, you can use it to do for rows. We can also subset multiple elements, right? To do this, we need to use C along with the index notation. For instance, M matrix row 2 and I want columns 2 and 3. So you can use C with that matrix, with that inside the matrix notation. So you will get, it will fetch all the elements in second row in columns 2 and 3. Also, subsetting works through column names and row names, and it could be combined use with indices, right? And it's similarly you can work. It works on logicals the same way it works for vectors. You can subset using logicals. So what will M of 5 print? What does that mean? What does M of 5? If you have a row index and a column index, and you are just specifying one number here, and what's the rationale behind this? And what does this subset print? Matrix C2, 3, C1, 2. What is this subset? What does this subset give you? Matrix arithmetic. Row sums and column sums function provide the sums of rows and columns. Okay. Basic arithmetic operations involving matrix and scalar hold just like vectors. So just like vectors, you can combine matrices. It's nothing fancy in here. And if you are dividing a matrix by a number or doing any arithmetic operations, it's going to do element by element basis. So it's going to divide the number by each the factor that you given. How about matrix and a vector operation? Can you combine a matrix and a vector? So you have a matrix here. I'm creating a 3 by 3 matrix and I'm making a vector 10, 20 and 25 and I'm subtracting this m minus v. What happens in this case? Why does this give you an answer like this? Okay, so remember that first of all recycling, right? So when you have a matrix and a vector, R immediately notices that, oh, this is a vector. So it actually it's a synonym. It tries to convert the matrix into a vector into a matrix, right? This result is same as this. So R always recycles. When you have one vector less than the other, it's not going to combine, it's just going to do that. And so it's very convenient, but you have to be very careful when working with matrices, right? And matrix multiplication is element wise, unlike standard way of multiplying matrices. How do you multiply two matrices? You remember high school? Okay. Do you know why it is done that way? All right. So there is a nice interpretation for why you do that way. Okay, so that's going to be covered in linear algebra. But in general, but this is different. This is not linear algebra, where the matrix multiplication just does it by element. So the principle of coercion and recycling works the same. What happens if you subtract, add, or multiply two matrices of different size? You can try that out. All right, so that's the material for today. Okay. So what you're going to do is you're going to do all the classworks, and this will be assigned as an homework.